Weather prediction has come a long way from merely observing cloud patterns or astronomical movements. With the advent of technology, we've seen a remarkable shift in weather forecasting techniques, most notably the application of neural networks. Neural networks are models of artificial intelligence inspired by the human brain's functioning. Much as the brain learns from experiences, these models learn from feeding on historical and present data to generate predictions. Weather forecasting is one such application where neural networks have demonstrated promising innovation in recent years. The journey of integrating neural networks in weather forecasting began in the late 20th century. Following research in 1988 by French scientists, a primary system of predicting weather via artificial neural networks was introduced. It was based on the idea of automated learning from a multi-layered network of artificial neurons. The system adapted to statistical patterns in the input data, thus forming a predictive model. However, this initial model posed challenges, such as the risk of overfitting, especially in complex atmospheric behavior conditions. Despite these obstacles, research continued, leading to the use of multi-layer perceptron, MLP, and radial basis function, RBF networks in predicting weather conditions in the mid-1990s. In the modern era, newer techniques like convolutional neural networks, CNN, and recurrent neural networks, RNN, are being explored for further improvement in the forecasting process. The significance of neural networks in weather forecasting can be gauged from their ability to predict complex weather patterns efficiently. Since these networks learn from previous data, their forecast accuracy tends rather high, especially for short-term predictions. Neural networks can swiftly extract implicit, complicated, and valuable relationships between input and output datasets. Thus, they can handle the voluminous data which meteorology requires for precise forecasting. Also, neural networks can offer localized weather predictions, which is remarkably instrumental in agriculture, aviation, and disaster management. For instance, localized forecasts can assist farmers in predicting rainfall, enabling them to make informed decisions about irrigation and harvesting. Similarly, accurate forecasts are crucial for air traffic control and flight scheduling. However, incorporating neural networks into weather forecasting isn't without its drawbacks. These networks are fundamentally black box models, where the relationships between variables are implicit rather than explicit. Thus, while they may generate accurate forecasts, explaining these predictions remains challenging. This black box nature hampers meteorologists from obtaining insights into atmospheric phenomena beyond the prediction. Another major challenge is overfitting, where a neural network might perform exceptionally well on training data, but fails to predict new, unseen data effectively. Overfitting is particularly challenging in weather forecasting due to the complexity and inherent uncertainty of atmospheric behavior. Furthermore, preparing and cleaning the large datasets required for training these networks can be resource-intensive. Not to mention, ensuring data quality and resolving ambiguities pose significant challenges. In conclusion, the application of neural networks in weather forecasting marks a significant wave of technological advancement. Coming from the initial phase of experimenting with these networks to modern, sophisticated techniques, the journey has been transformative. Yet, it's not devoid of challenges. The black box nature, potential overfitting, and the need for data preprocessing are substantial issues. However, the positive consequences such as increased accuracy, efficient data handling, and localized predictions are prominent enough to motivate further exploration and innovation in this area. Despite the challenges, the advent of deep learning and the increasing computational power are set to take the fusion of neural networks and weather forecasting to unprecedented heights.